Hi, thanks for tuning in for this session about Couchbase's full-text search system and service. This title is Simplified Text Search is just a teaser to get you into the idea that doing text search is actually easier than you might think. If you've been kind of holding off on it because it's a new paradigm for you, hopefully you come away from today's session not being afraid of it and getting your hands dirty, maybe even following along in the background, doing some of the things we're going to look at. So this is going to be a high-level overview of a few topics, helping you understand how people use full-text search capabilities and how Couchbase's system is architected to help support kind of your system, your architectural needs in your enterprise. My name is Tyler Mitchell. I'm a consultant for product management and product marketing teams within primarily data-focused startups. I worked actually with Couchbase on the initial launch of the full-text search service. So I've got some background here and look forward to sharing a little bit more of it with you. So we've got about 7 kind of chapters in this talk. We're going to introduce the concepts of full-text search, see some of the examples that you're already kind of familiar with, and help you understand how they work behind the scenes to really empower users. You'll learn the general concepts of search, as well as applying it to getting started using it with Couchbase in particular. I'll leave you with a list of resources to access at the end as well. So I think that this slide needs like no introduction, but I will do it anyway. If we had to kind of rate the most top used graphical user interface component of all time, I think the last 20 years has shown us that it's going to be this search bar. So much so that we talk about searching the internet. We don't necessarily talk about surfing or browsing so much as we do finding the things that we are after. The search interface has been the primary way that humans have interacted with all kinds of digital technology, and it's only going more and more towards that as more information is digitized and new processes become digitized in their first generation. Think about the different kinds of interaction that we have with this. It really is humans entering in information, pressing a button, and then getting all sorts of information and search responses back that really go across the spectrum of human life. And when I'm talking about search, I'm not just talking about typing in text, although we're focused on text today. But we know that there's everything from searching your emails to finding where you are to playing movies and music, buying things, planning trips. All of these things start quite often with a search bar on a website for the end user to find what they're after. But behind the scenes, there's actually a very complex kind of web of technology that's being used. And it's changing over time as things become more streamlined. But just to give you a sense of how cumbersome and complex some of this background technology is, you think about it, every time you press enter in that search bar, it's going to some system. Maybe even every time you're typing a letter into a search bar, you are actually sending information back to a system behind the scenes. That system or that application is then sending a response back to a search-related system that has some indexes already created to help find the information you're after. That information is coming from another kind of search engine that's doing the indexing as well. It's often synchronized with some kind of transactional or operational database. And that operational database is fueled by input from tables and documents, machine data, etc. And those tables are generated also from machine-driven data, transaction logs, etc., coming into the system in another kind of application. So you've got the search applications on top here, and on the far right you've got whatever other applications that are collecting information. And then in the middle here we also have other types of databases, other kinds of analysis from NoSQL or document databases, graph databases, geospatial databases, analytical databases, OLAP, etc. And to top it off, we also have just the whole mobile platform, which I encourage you, if you don't understand Couchbase Mobile, go see a session about Couchbase Mobile, and you'll see how it all ties in here as well. Now, most of the stuff I'm talking about around full-text search also applies to Couchbase's full-text search implementation on mobile platform. But this is a very kind of precarious system in a way, or architecture. For those that are into system architecture and want simplicity and clarity, you'll recognize that we've got a few clouds on this diagram, kind of showing amorphous groupings of data and resources. The arrows here and the lightning bolts all represent some kind of like plumbing behind the scenes. It's a very critical part of this overall picture. So this is a kind of a typical search architecture, segregated from the transactional database, from the search-related system, to the other kinds of analytical services that you might have. The takeaways to consider when you're talking about search architectures really comes down to how modular do you want your approach to be versus how monolithic. Now, there would be a time maybe 20, 30 years ago where it was you bought one system, you bought, if it had the capabilities, good. If it didn't, you were stuck, and you would either have to roll your own or hope and pray that the vendor will add it in. Well, that's not a great solution. But also the super modular environment isn't a great solution either. It can be, especially for prototyping and for pulling together kind of information architectures that are not normal or not common. But at the end of the day, each one of these little orange pieces or blue pieces on this chart require a different kind of system administrator, a different kind of database, and a different kind of approach to building your own platform for your applications. And quite often, like we say, there's separate systems for every function kind of in this tool chain. The one point I really want to spend some time talking about is this idea that data plumbing is key to this. The idea of moving data between systems has gotten easier and easier as different systems, messaging systems, things like Kafka, Confluent, and other kind of back-end message buses and things like that have helped drive more of the streaming architecture. And that streaming architecture has helped feed operational databases and keep them synchronized, for that matter, with other search or graph or OLAP databases, etc. But there is a price to be paid. Everybody who's done ETL processes knows that the more streamlined you can make your plumbing, the less cumbersome your overall system is going to be. If you think of every kind of interaction in this diagram is actually fairly simplified. Every interaction between a system, a piece of data, a user, an application is actually a potential source for failure within your system. So the tighter and more robust that you can make your platform, the more safeguarded it's going to be. So pay attention to that data plumbing and don't just go, oh, well, we've got something that takes care of the data plumbing. Instead, we want to kind of focus on the idea of how do you take advantage of the data plumbing that's there, that's the most efficient for your end use. So let's just take a kind of a 30,000 foot view here, talk about what search looks like in the real world. Now you all know already what search looks like because you interact with it every single day on pretty much every device you have, whether it's an Alexa or a phone or a laptop or a website. But I thought I'd just pick a few kind of different examples to show the different kinds of responses we get from search systems. So I've picked a few examples that are really like not popular examples. For example, we go to a Canadian revenue agency, go to the tax man here and search for offshore compliance, and you'll get some responses. And let's just kind of enumerate what we see here. We get a summary of how many search results or how many documents within their kind of database have a match. We get a title. We actually get a little tag in there. You can see the little blue color showing kind of what the resource is that they're pulling the data from. We get a link to the kind of deep dive into the actual document, a date or a timestamp, and then we get a chunk of text showing the context of the search result, and it's highlighted in that text as well. So we can tell pretty quick by looking at that text whether it's a document that we're actually interested in. Oh, I should back up and just say, and we've received these in a list of some kind of order. We don't, unless we dug into more of the advanced search capabilities on this website, we wouldn't necessarily know why they came in this order. Now, switch to something totally different, this icon website where you can type in a term and it will look for matching keys or matching tags in each image that's been stored in the database. You're getting back the icons that have a very specific match, and you're getting back in some kind of order, and you're getting to preview the actual content. So two very similar but very different kind of search outputs. Now if we switch over to like a Wikipedia kind of interface, this is interesting because I don't know how many of you use the search bar there. I end up using search right in in the Chrome or Brave browser and go to wikipedia.org, I press tab, and I just start typing in the URL. But when you go into the search interface and you type in a term that actually has a perfect match to a page name, it will auto-complete some of that for you, give you those suggestions, and lead you maybe to the exact article you're looking for without really having to feel like you've done a search, found the right result, then went into the result. Instead, you just press enter, it takes you right to that page. So the output of the process is the page. And there's no list of alternatives, for example. And then one that's maybe not so fringe here is searching for a type of product on a website. You get back again kind of these relevant ordered search results. So you can see in the kind of the top right there, sorted by relevancy. You can change that by price or by some other category. But the thing I wanted to point out here is you get these categories down the left sidebar that have products that match your search results. So you get the search results, but you also get the categories, you get some price ranges, you get some other filters that you can add in. And quite often those filters are smart filters based on the real data that's in the database that matches your search. So it's kind of a nuance there. We'll come back to that. And then Zillow, I like this one because it's a geospatial example. A lot of my background is in the geospatial world. So in this case, we type in the search bar, we type in the location we're interested in general, and it shows me a bunch of dots. I've done a bunch of other filters like price and lot size and things like that. Shows me some red dots. I can then zoom in, and by zooming in, I'm actually creating a filter based on the coordinates on the corners of this map, and then it's only showing the results in the right-hand sidebar that match that kind of geographic filter. So those are just some of the kind of search examples that you can think about that we interact with every day. And quite often we don't think of them as kind of different kinds of results, but we've learned to accommodate the kinds of results differing between different websites. So just to summarize what we've experienced in those different search tools, we count the documents, we list what titles are available, we can maybe preview the context of the matching text, we can find where to get the more drilled down detailed document, we can even go a little more advanced, do these geographic searches, sort things by a relevance score or some other sorting mechanism like date or price. And then we have these categories and ranges that of matches, and we call them facets in the search world. So these are all common features in search capabilities of every site. My whole point that I would like you to take away, if you switch off at this point, just remember that all of these capabilities are built into most search systems. Don't go and roll your own, because there's, no matter what language you want to program in or what database you're using, there's a solution there for you, and just start using it. And it's the same with Couchbase, Couchbase Mobile, Couchbase Server. We have these capabilities built in. So that's a preview of what a search system might look like and the different kinds of results that come out of it. But how do the search systems work in general? I boiled this down to just a few phases, but we'll start with phase 0 here, where we assume that we've got some data loaded, that there's some data that's coming out of an operational system. It's been transformed to meet the kind of search requirements that maybe you're hoping to use, and that the data is kept up to date and loaded or reloaded into a search system from an operational database. And phase 1, and these are kind of arbitrary or artificial barriers between these different stages. This is all kind of grouped together in some systems, but there's like an indexing operation that gets kicked off. So we have an operation that works on the database that receives all the parameters for how you want to index the data for your specific search application, and it will process the data in a very particular way using the kind of analysis parameters that you've specified by your search application. And then kind of when that's kicked off, behind the scenes, that text analysis actually happens. Things such as tokenization, where it decides, do we break up a sentence into multiple small words? Do we keep a couple of words tight together because they're a username or an address? What kind of characters do we get rid of? Which words do we get rid of? And how do we store the information so it's ready for retrieval later on? And that's step 3, actually doing a search query or doing a search The user or the application kicks off a search request, tells it which index to go and look into. The analysis process then is kicked off against the input terms that have been specified, and goes through that kind of step 2 again, but using the end user's input text, and then matches it up with the actual text that's been indexed. Gives it a score, returns that to the end user in the application in question. So that's that kind of the main phases here, and a good system will kind of wrap this all up and make it a little cleaner to the end user. But you can come back to the slide and understand a system that you go and pick up might only do one part of these 4 steps. And again, step 0 is all about plumbing and getting that data to the point where the search system can start to do analysis. So you can see why that's really important. Now, text search isn't the solution to everything. Those of us who maybe work with it more than others would feel like it probably is the solution to everything. But there are times where it is particularly advantageous for a user to have access to a search system. Let's take a little bit of a historic meander through what the web used to be like, or put our mind in a little bit of a different place by looking at a few common websites today without search capabilities. Yahoo Answers, I've gone into this website and removed the search bar. And how would you actually navigate the site? So now you've got some kind of question or answer you're looking for. You need to translate in your mind which category in their 20 categories here will your answer be found. It's not always so simple, and I think actually over the last decade or two we've probably grown fairly lazy in our cognitive abilities to categorize some of our questions. So for example, what if I want to understand maybe there's a family conflict about whether we should have turkey for Thanksgiving because it's not healthy to have it, but I want to maintain my family relationship. Am I going to go under health? Am I going to go under food and drink? Will I go under family and relationships, society and culture? Like, there's so many cross kind of category examples you could think of there. So this original kind of idea of having categories that you start and drill down into, which is kind of where the web started from before Google, really I think would take a lot of us by surprise if we had to use it today, because we're so embedded in using search. So I would say you want to choose search when you've got kind of cross-category information that you want to make available to end users. And this is the Amazon website, specifically the book section, kind of give it that old school feel here. They too use the categorization system to help kind of maybe to browse through books. But how many people browse through books? I don't know. I don't look for the best books of the year. I don't look for today's deals. I don't look in the For Dummies store. I search for a book by name. Or I want to search for a quote, and I look for that specific quote. So search solves these problems by helping make that match between kind of these arbitrary idea of categories and the actual kind of self-categorization maybe that the author has done. We don't know what an author is going to do with their book and which category they're going to put it in. We can guess, but it's not something that we need to spend a lot of time doing. So this is YouTube without the search bar. Gives you this general page with some recommendations. Almost nothing I will look at on here. Okay, I might look at the bear sits next to guy. But what's the next step if you don't have search in this application? You might go to trending. Ugh, don't recommend it. But then the categorization system, it looks like they have on the lower left here, isn't really a categorization system. It's just kind of their top videos in certain categories. So again, you're always going to be looking at what they think is the best, what they've kind of prioritized as important. That doesn't always mesh with what the user needs. So one way to think about it is choose search when you actually want the end user to become the application. So there's a certain amount of logic with finding categories, finding groupings of content. We'll let the user define what those kind of combinations would be. And I can tell you, we're all really good at doing this as we become more mechanized in the way we kind of enter our data in. By doing so and using search, you can actually remove constraints that were inherently there, but we didn't really think of them as constraints, because when I've got a terabyte of videos and I want to make them available to my end users, I can put in a title and a thumbnail and feel like I've done a lot of great work exposing this information to my end users. But I've really constrained them into only being able to see thumbnails and titles, and not really giving it the metadata that they could search for. Again, too, when you think of maybe more in a business intelligence type environment where you're creating reports from data, there are these ideas of fixed representations of reports that might be suitable for certain tasks, but there's also just this idea of having tools available to the end user to find what they're after. Maybe your financial statement is great for the board, but when your operations team needs to review something, they need to find a specific field in the data that they can only find by searching for through your list of field names or through other set of reports or applications. So the idea of when you want to give a tool to the user, remove constraints, and avoid fixed representations, that's when you would probably want to choose search. And again, these are some of the examples of things that you might want to do. Boosting is an important term in text search, and we all inherently know what boosting does, but we didn't know it's called boosting. But it's when you put in a term and you absolutely want that one term to match. Maybe all the other terms are secondary, but we tend to know what we have to put in to get the results we're after. You can also, another scenario that's important for using search is when you've hit limits of what your query language, or SQL, or in Couchbase's case, Nickel, maybe when you hit those SQL limits. So maybe there's been some very complex representations. So let's look at one example here. So I'm querying one table, and I've just kind of made this little variable called search term up. This isn't a real example that would work anywhere. But I don't know if the user was searching for a term in the name field, the location field, or the description field. But I kind of do the pray and spray approach, or grasping at straws approach, and just kind of query several of these fields. Well, very inefficient if you know all they're really wanting to do is find documents that have this term somewhere in the table. Or maybe you've got crazy like clauses. If you find yourself getting down to this stage where you don't think that they're going to get like an exact word-to-word match, so then you start throwing in wildcards around your terms everywhere because, oh, they might spell it a little different. They might be inside a sentence, not at the beginning or at the end, etc. That's really kind of starting to, the more like clauses you have, the more evidence there is that you want to use a search system. That's a good rule of thumb. And then finally, what if you have a real complex set of tables in your database, or in Couchbase's case, a whole bunch of different types of documents in a bucket. So let's say we have travel history, travel plans, current travel bookings, or whatever you want to call them, and you're kind of searching across all three of these tables in one query or in three queries. That's really pushing the limits of kind of good design. So choose search when you also want kind of the capabilities that come with text analysis. So I've put a little URL here at the bottom for what I'm calling the online analysis wizard from Blevy. Blevy is the name of the actual text analytical system library used behind Couchbase. And Blevy has its own website, and you can go in to check out this analyzer where you type in some words. In this case, I typed in connecting computer networks as a challenging set of tasks. And I chose from this dropdown a certain kind of analyzer that I want to use. There's dozens of different analyzers. Most of them are for different languages, human languages. And then there's a couple kind of categories of them. So if I have, for example, I want my input text to be treated as one homogeneous unit, one token, we would call it, or one term, then I would choose this keyword thing. So maybe I have a blockchain address or an email address or something like that. I would analyze it with that kind of keyword approach. Now, alternatively, there's a thing called a standard analyzer in Couchbase where it'll break it up into the rough groupings of kind of common terms, in this case using kind of just white space as a kind of a tokenizer, and then throwing out some of the more common words like is, of. And then there's an analyzer called English analyzer. You'll see there's dozens of languages there, 26 I think. And this gets a little more nuanced and is really, really super powerful. So you'll notice like the terms that they've picked out, that these kind of 6 terms here are actually what we call stemmed matches. So the word connecting actually really refers to the word connect. So if I did another search later with the word connects or connected, it would still match this term called connect. And these ones that are listed here are the ones that end up in the index. And so when your end user comes in and searches for a term that's similar to these stemmed terms, it will find the match and automatically find it in the context, in a language context that makes sense. You also should consider using search when you don't really know how the data will look or how the search request will look. So in this case, there's the ability to use regular expressions, and I don't have an example of that, but there's also an example here of showing what's called a fuzzy search. So the end user has typed in this word beautiful with a letter missing and has said replace, add, or delete up to 2 characters using this fuzziness setting and find matches that are roughly similar to this. And you'll see here, match the word beautiful. It'll match many words and some words you wouldn't think of, because what if you replaced the B with another letter at the beginning and removed a letter in the middle? There's so many combinations. Of course, this takes a much more of a system hit in terms of performance, but it's incredibly powerful. And I think we all notice when this kind of approach is not used in an application. We're like, man, I know how to spell this word more or less, or this term, or this book title, or this author's name, and I just can't figure it out. If you had just a fuzziness factor of 1 or 2 turned on, it would solve so many problems. So those of you who are application developers, I beg you to try to implement more of that wherever you can. And then we talked about this idea of facets, creating categories and counting up kind of how many matches are in certain categories, giving you the ranges of prices in your search results, and things like that. Though, if you want those, then you want to choose search. In this case, I just show an example of where the actual search term here is called horrible experience. It's searching through some hotel reviews, and I've said, okay, look in this field called type and give me up to 5 different types in my results. And in the response here, it says, oh, I found 377 documents that matched horrible experience in the hotel documents and 50 in these landmark documents that we had in the bucket. And these are from the travel sample bucket, by the way. So when you want that kind of experience, you want to use search to find your answer. And then a more advanced use of facets, you can actually go in and define date ranges so that you'll get your response grouped with counts for each range of your search results. And you get not just the search results back in the list of hits, but you get back the count of documents by a numeric or a date range. So facets are pretty powerful when you start to use them. So kind of moving from the idea of when do you choose search, I want to talk just a bit about when should you choose Couchbase Search. And I'd say when you're building a comprehensive solution that is not just a document store where you're going to retrieve, or a key value store where you're going to retrieve certain data sets, but when you want to also be able to use global secondary indexes, so the indexes behind the Nickel SQL-like query search. And I'm using GSI here, but to differentiate from search indexes later on in the presentation, and Nickel queries to differentiate from search queries as well here. But when you want to have a full stack where you're actually able to do queries, searching, and then analytical queries across large data sets using the SQL++ capabilities, that's really important. And that's when Couchbase really shines, because you've thrown documents in to a database, and then you're exposing it through multiple types of interfaces. They're all accessible through an SDK, single SDK for the application developer, and they are all installed in the typical installer for each node that you put up. We'll come back to that in a few minutes. So if you want to be able to do search, use Couchbase Search across multiple types of documents that are in your database, this is a good way to use it. You don't have to really precisely define what tables, what fields are exposed, etc., unless you want to. And then there's also the Nickel query integration has some search functions built into it that allow you to take advantage of kind of the text search capabilities a couple different ways, just using within this kind of the SQL-like language. And then, like I just said a minute ago, if you want a simplified architecture for the kind of this stack of a comprehensive solution, Couchbase is a great approach because it's a single installer. There's one type of system to administer. They're all tied together, and it's one company that can provide all the support you need. So 3 steps to get you to start searching today. Hope you're still with me, where you can follow along, get your hands dirty if you so choose. Just download the Couchbase server install and follow along. These are the 4 steps we're going to go through, getting things set up, and then building, indexing, and searching the different data sets. When you add a node, you get this little screen where you say, oh, I'm going to add in this IP address of this node, and then you define how much memory is available for each service. If you say you don't want data on there, you do a checkbox, you just turn off data, or you turn off search. If you want just a search node, you disable everything else and turn on search. And then you can do that right out of the box. You can leave everything turned on, change the amount of memory you want to assign to each one, and that will give you different performance capabilities. There's a sample bucket of data called travel sample. I encourage you to go to the settings tab, then choose sample buckets, and then enable the travel sample and say load sample data, and you'll instantly have a data set to start playing with. And that's pretty much the data set I'm using in these examples. So you could go and do that right now. It only takes a minute. Building the index is kind of the second step. What you do is you go to the search tab here. Again, don't be confused by query and indexes in the web interface here for Couchbase. That's for the global secondary indexes and nickel searching, the SQL searching. Search is its own tab, and it includes indexing as well as searching all through one tab, and you'll see in a minute. So we give it a name. We tell it which bucket has the documents in it we want to analyze. There's a default setting turned on. I'll come back to this in a minute, but just hit the Create Index button, and you'll index all the documents and all the fields in those documents. Okay, so that's a default. The default approach is not optimized for performance. It's optimized for getting up and running immediately with just clicking one button. Then you're left with this little screen showing how many documents have been indexed, what the progress is, how many more there are to go. This only takes a couple minutes on a normal machine. And then you're given this little search bar. So now you can start using this index all through the web console interface without having to write an application, use a curl statement, or anything like that. So start typing in a word there, and you'll get some search results back. In this case, I typed the word beautiful. It gives me back all these hotel matches. There's hotels, airports, landmarks, a bunch of other tables, document types in this bucket. And they're blue because they're actually URLs, or they're hyperlinks to go and look at the actual document through in detail. Now, with a few changes to the indexing, and I'll come back to this in a second, I can actually get this kind of result back, where it actually shows me the term highlighted in context of the fields that I've indexed. And I'll show you what I did in a few minutes to make this happen. But this is really powerful for prototyping and testing. And I can even do things like tell it which field to look in to filter data even more precisely. Let's move some things here real quick. Okay, and then we can actually access the data using a nickel query as well. So if you do go to that query tab in the web UI, you can type a query like this, kind of a normal SQL type statement, and then you can use this search function to actually specify the index, the name of the index here, and then the search criteria that you have. I won't go into kind of all of the structure in this talk, but I just wanted to show you this as an example that you can use search to get a list of document IDs, and then pass that over to the query language to grab the other columns from those documents, do groupings and aggregations. And then there's also this ability to just tell it to use a full-text search index if it's available, and you don't actually have to change the rest of your statement at all. There's some limitations and things that I'll encourage you to go look up in the documentation, but you get the idea that even if you don't want to ever use a search system specifically, the capabilities and the fast response time and the loose kind of term matching capabilities are really powerful and are exposed multiple ways. All right, so here's an example of using a curl statement for doing a full text search query. Mainly this the URL here with a username and password that you need to set in the security settings in the web console. The name of the actual index is in here, and then the main part of the payload is this query statement right here. And it's really simple and it's easy to use, and you can go look up all the different kinds of queries that are available from full text search within Couchbase, and there's a lot. This is what it looks like when it's running in a Postman environment. I've given a little breakdown of what the actual URL looks like for the post command, and an example, really basic query example in the, down below. But of course, if you're a developer, you're going to want to, I should say, within Postman you get this hits object back, and each entry in that list is a matching document with an ID. And then if you've got kind of the capabilities turned on to analyze the position within each text component, it'll tell you where the word is that matches the terms you've put in. That's what the position end and start mean. Now, if you're an application developer, you're going to maybe want to write your own application instead of just using REST API calls. And I highly recommend this, especially to separate users from having access directly to the REST API running on the text service itself. There's this is the NuGet.NET client library URL there, and a really simple application that just does a query, and you can see we connect to the database, we connect to a specific bucket, and then we pass it, we create a query for a match query in this case, and then we actually just print out the number of hits we've got and the document IDs for each hit. So it's a very simple program. Could probably remove 3 or 4 of these lines to make it even simpler, but there's support for 7 or 8 different programming languages, and they're all included in the base Couchbase library. So the next step is to really go back and optimize the index, get comfortable tweaking things. And in this case, I should have turned off this default item down here and done an actual, just specified very specific sets of fields that I'm really interested in. The default one indexes all the fields, and that's not ideal for most situations. And it will create a much larger index than needed. In this case, I've actually told it what's called a type mapping here. I've said, look, I only want to look at documents that are hotel related documents, and there's a field in each document called type, and it's specified up here, and I type in hotel here, and then under there I created these other little child objects, description, name, and then an object called reviews, and then I'm creating a field in this situation called content. At this level, I basically defined 3 fields in all the documents. They only pertain to the hotel documents, and that will create a much more efficient full text search optimized index. I've turned on this store checkbox, and that's the one that allows you to retrieve text results with your query without actually having to go and request the full document from the data nodes, for example. We'll come back to why that's important, but that's what gave us that kind of that preview view I showed you when we typed in the word beautiful, and we got back some results with text in context. So I want to kind of focus in on those specific fields of interest. I don't have the example handy here, but there's also a drop-down box called Analyzer. We talked about those different analyzers before. Each field can be analyzed for indexing purposes differently, depending on your usage. And then the indexer remembers what kind of analyzer was used, so when you're passing a term in, it understands and will match your term appropriately with the same analyzer. Go through a bunch of these things, test the performance, test how much disk space it uses, see if it's an appropriate match for you. Okay, so next we're going to talk about moving towards production. So you've done all your prototyping and testing, maybe you've got your application developed, but it's important from kind of day one to be thinking about how you will want to move towards a more of a production environment. Let's see here. The one main concept I want you to think about is called multi-dimensional scaling. And in Couchbase, this means we can actually make like a given node in a cluster bigger, or we can add an additional node to a cluster to make it wider. We'd say scale up or scale out. And I'll go through a few of those scenarios so you can understand the concept, but I'm sure there's other talks in the event this week that you can go and learn even more about multidimensional scaling, how to build resilient applications within that framework. But if you think about maybe early on, you've got a single laptop running Couchbase. You're running all the services of Couchbase on one machine. It's a single node cluster, and you've got your application you're building being tested on that node as well. So you've got your shared memory across all this, shared disk, all on one machine, and that might be fine while you're doing some basic development. But as you move along, you'll want to start to kind of scale out, add a second node. Maybe you've got a machine that you're running Docker containers on, even just for a good test environment. You could do that, or get two different physical machines. And you can actually set up replication between the different services between those two nodes. It'll share the load for the memory and disk across those two machines. And that's a great test cluster, especially if you can move your application off of that cluster onto another machine to simulate a bit more of an operational environment. And then kind of the third approach, which would be more of a production kind of cluster, would be to actually only install the components you're really interested in. Give them their own disk space and memory allocations on their own kind of their own nodes that are dedicated to them in particular. So in this case, we've given 3 nodes to the data service. That works out good because then you can say I want each node to be replicated at least once onto another node. Same with search, and then we'll copy and keep replicas on different machines. But this is just a general example. I'm not saying that you need 9 nodes to do a production cluster. Many users will have less than this, and they'll bundle up the GSI index and query into one node, search as its own node, and data as its own 1 or 2 nodes as well, depending on the size. And then, but you might find like that your search application doesn't run as well as you want it to run. In that case, you could give it more memory and more disk space. And that's kind of what the purple is representing here as the search service expands and scales up. Or you might find that you just have more data volume than your data nodes can handle, so you add a fourth data node into the environment. So these are both valid approaches depending on the barriers or challenges you hit. And this is general for Couchbase Server, but is very relevant for search in particular because it has its own indexing and querying components built into it. And then kind of this other scenario I just want you to consider is that sometimes it helps to have the data on the same node as the search indexer. So there's nuances to when this may or may not be valid or more useful, but consider that sometimes you want to piggyback the data service with other services so that you actually don't have to go across the network to keep the data up to date for the indexer to get a hit from. So I won't go into more of the details around how all of that happens behind the scenes. Is much more technical than I want to get into. But the other concept, there's multidimensional scaling and there's cross data center replication. So initially you might have a production cluster that runs and it streams and connects to a second cluster. These are all configurable, by the way, through the web UI. And it's just that backup cluster is there in case there's a failure on the production cluster, and the application can just switch over. And you can program that into your application to switch over to the other cluster. But more likely, eventually what you're going to want are multiple production clusters. And Couchbase can operate in this masterless environment where maybe you have 2 different geographically located clusters and you want them to remain synchronized with each other. You might even have 2 separate application servers depending on kind of the load balancing environment you have, and they might use the kind of their own clusters, but then when one goes down it can hit the other one if it's still available. So that really builds in the complete picture of resiliency for your Couchbase related application as you move into production. One of the other reasons you might want to use Couchbase as you move into production, if you've already got Couchbase running in production and you would like to add search capabilities to your application, one of the ways I recommend is using what I kind of previewed earlier. It's called flex indexing. And it's basically, if you already have a query-based application that's using nickel queries, consider creating your search indexes and then using this use index using FTS parameter to tell your queries to start using the search index if it's available. This way, you actually don't need to change your application. except for just slight modifications to your kind of SQL clauses here. That's one way that you could kind of move towards production and test things out, and maybe be an interim step for while you're writing your own search-powered interface instead of a query-powered interface. I have a video here, we'll see if it plays, but it's basically showing the statistics monitoring capabilities of Couchbase. It's very sophisticated, very in-depth and detailed. You can look at many different levels of statistics to compare resource utilization. This is my single node cluster just running on my laptop. But I can see overall the memory usage, the disk usage for the cluster, or I can go right down to looking at what specific nodes and how they are matching up with swap usage, HTTP requests, how much RAM and CPU is available, etc. Or I can even go into more depth. There are 100 charts available in the statistics options for each node in the cluster. Everything from the size of data on disk, how many operations per second, how many disk writes are queued up and are waiting, another good thing to watch. How many FTS queries are actually happening? And you can see whether the service can keep up with the queries, or do they just keep growing and growing and get backlogged. Disk space for full-text search is listed there as well. But there's also search index specific statistics, which are incredibly useful. You can see the queries that are hitting these index, how many items are indexed, right down to how many files are partitioned on disk for each index. Is incredibly powerful. And when you're troubleshooting, especially performance, you want to really dig into those resource conflicts that might be occurring between different services in particular, or just in general on the machine. Maybe you've got other applications running on that machine outside of Couchbase that are making it harder for Couchbase to run. That'll be one way you can find it out. I have this on this slide, fun things to try, and I got the order a little mixed up here, but Go Mobile. I haven't barely mentioned Couchbase Mobile in this talk because most of the full-text search capabilities that I've shown here are also available on mobile platform. So we think of Couchbase Search in general. Sometimes you might need to drill down to the nuances as the differences between the two, but you can do search on the mobile device, and it comes with it built in, and it comes with the built-in kind of synchronization capabilities using Couchbase's Sync Gateway. So don't take any of this to mean we're just building web-based apps for PCs. But some other fun things to try are spatial queries. The capabilities, I didn't dive into too many here, but are that you can do these rectangular-based geographic queries. And I show kind of one of the query examples down here using a couple different ways of kind of notating the longitude and latitude, for example, in this case. And you specify what field has these objects in it. But you can also do a polygon-based search, which is new in 6.6 Couchbase. And you can also do a distance thing. So you specify a point and then a radial distance, and it will select documents that have matches within them. So that's really cool stuff when you start to interact with your data in a graphical way that usually goes beyond basic business intelligence tooling. I call this cross-document search. I found is really powerful for certain applications. So let's say you have a typical kind of relational database structure. You've got 4 different kinds of tables or 4 different kinds of documents in your bucket. And usually we think of, okay, query this field in this one, query this field in this one. But what you can actually do is build an index for search that goes across all those document types and categorizes or indexes very specific things. So for example, you say you have a username or an email address, you could search just for that. It would search across all the documents and give you the matches for those types of documents. This is really powerful too, and I know users that are customers of Couchbase that are using this to help understand their kind of user base. So if a postal address or some kind of transaction ID or a blockchain address or something like that is used, then you could find where it's referenced in any of the tables in your system. And then finally, I really want to encourage you to take time when you're building your applications to try to understand what the user is thinking. And I don't just mean like what kind of data access they're going to need, but think about the kinds of queries that they're logging. And if you can write your application to log those queries, you could see them getting frustrated probably, where you might want to tweak the indexes or optimize your approach, where they're typing in the same search term 5 different ways, seeing that there's nuances they're expecting the search system to find, well, you could probably go back and make the index a little looser or a little more specific depending on the need. There's some really interesting things you could do there if you just sit back and think with that mindset. This is one of the final slides here. I just want to go over 5 or 6 different resources that are available, on the Couchbase website. There's a couple great white papers I encourage you to check out. If you want to dig into the architectural background on Couchbase in general, find the Couchbase Under the Hood Architectural Overview. If you're not sure whether a NoSQL database is for you, the NoSQL white paper is a good example explaining how people use it. There's a training course specifically designed for full-text search. It's comprehensive. It's got dozens and dozens of slides, videos, walkthroughs, and slightly different data sets, so you can try out a few different approaches. Documentation has a specific learning and coding sections dedicated to search, the search service. So if you're looking through the documentation, you want to find search-related stuff, it's called Search Service. And then there are articles on the blog that actually go into amazing amounts of depth with real use cases and examples, everything from geospatial queries to understanding what's in a new release. And that flex indexing that I was talking about too. There's great postings on the blog on those topics, and you can search it through this category tag here and get just the full text search ones. So thank you for coming and listening today. Hope you're enjoying the rest of the event. There are other talks that are talking about search. Go check them out. I know there's at least one from Marty, who created the product in the first place, the full text search and Blevy engine. Check that out. Check out the nickel flex indexing session, and drop me a note if you want to be in touch. Thank you very much.